Hello world, I'm Evan Gudmestead, an instructor of application and web development at Rankin Technical College. In today's video, we are going to review or refresh your knowledge of JavaScript fundamentals in 2025 using a very specific format. This format is where I lecture on a topic for a short amount of time, realizing that your time is valuable, and then implement the code myself, show you some code demonstration, followed by a programming challenge. So kind of a tiered approach of theory, introduction to a concept, followed up by a challenge. In this video, there are 8 programming challenges that I will encourage you to do in the JavaScript world to refreshen your JavaScript knowledge. Now, if you stick through this video, you will learn the following. Again, this is meant for the introductory JavaScript level. Now, this is the first time you're trying to learn JavaScript. This is not necessarily for you, but if you've seen JavaScript before, if you've been introduced to a for loop, maybe if you've wired up a button, this could be the right fundamental refresher video for you. The specific objectives that we cover, the understanding the difference and the relationship between JavaScript and ECMAScript. We go through some JavaScript variables, so we start at the basics, the difference between var, let, and const. We talk about primitive variables and reference variable, data type variables. We talk about JavaScript falsy values and JavaScript truthy values when using those inside of conditional if statements. We get into asynchronous JavaScript, of course, as we're learning the MERN stack. We want to encourage asynchronous JavaScript, so we get into the JavaScript event loop and all those concepts to write some asynchronous code. We get into ES modules. Of course, we're going to manipulate the document object model. We're going to write some basic scripts. Again, 8 programming challenges. We're going to be using looping and arrays. We're going to look at all the different ways to write functions. We're going to be working with strings and arrays and JavaScript objects. I want to explain briefly the methodology of what we're going to do over this lab, essentially for us, which is, if you look at this learning pyramid, this is broadly speaking, like my understanding. I think it's intuitive on how people retain and learn information. I've been lecturing as a teacher for a long time, and you can kind of see these percentages. I don't think necessarily are like scientifically like studied, but you kind of generally get the idea that from a lecture you might retain 5%. And again, this is kind of just broadly speaking of what a teacher lectures on. But then if you read something, you might retain 10% of it. Audio visual, such as a video, you're retaining more. A demonstration, so like if I do a coding demonstration, you might retain 30%. We get a discussion group going. Practice, ultimately, that's what we do at Rankin, is we practice the code. And then if you can get to the point, the ultimate pinnacle, we've all heard this, of teaching others, is really where you internalize the material. So what we're going to do here is we're going to start a little bit with the theory, a little bit of the lecture. We're going to jump into the demonstration. I'm going to demo some code, and then I'm going to have you practice by doing down here at the bottom of the pyramid. And then ultimately I do want, and we're going to talk about this in this class, you to teach others, and I'm going to explain how we're going to do that. Not part of today, but this teaching others part, but everything else. So I'm going to lecture, I'm going to demo, and we're going to practice, and that's really what we're doing today. So the theory, these are just my notes. I didn't put these in a PowerPoint slide. If you're offended by that, I'm sorry. But we're just going to kind of talk about some high-level JavaScript 101, JavaScript crash course. My students have seen, roughly 40 days of JavaScript before. So you guys are not new to JavaScript. However, it might have been a while since you've touched it. So we're going to go back to the beginning of what is JavaScript, how do you write JavaScript from the scratch, from from the ground floor. Okay, so this is going to be kind of a beginner into an intermediate level discussion here. Okay, but we're going to start at the beginner level. One thing that I find really interesting about JavaScript is it was created in 10 days. This guy here, Brandon Ike, if you want to like learn more about the actual creation of JavaScript, this guy's still alive, and he did a podcast on Lex Friedman. I'm a big fan of the Lex Friedman podcast, and I included that link, and you can learn a lot more about how it was. Like, this guy just didn't sleep for 10 days, and he created JavaScript. Why is that important? Because in the early days of JavaScript, it was sloppy, it was rushed, it was not well thought out. I mean, it was just literally thrown together. But it has evolved into what I say there is arguably the most popular language in the world. Why is that? If you kind of zoom in there, you could see on the Stack Overflow Developer Survey, the most popular languages, JavaScript is listed as number 1. This was last year's, 2024, but it's still the most popular language in 2025. The 2025 survey was just released. JavaScript's number 1. The reason it went from a really sloppy, ugly language to the most popular programming language in the world really is it's just been adopted by all the web browsers. All the web browsers have what's referred to as the JavaScript engine and can run code to make web pages dynamic. And so it's just one of the core foundational languages of the web. If you're learning to build a website, you're going to learn HTML, you're going to learn CSS, and you're going to learn JavaScript.
Those are the main ones, right?
Yeah, those are the foundational languages. And so it has evolved is kind of the next thing I want to say. Since its original creating. It's not like a language that it was just created in 10 days and it stays that way forever. JavaScript evolves, and there's actually new releases every year, new features, new capabilities of the language. And so around 2015, JavaScript started having this yearly cadence of new features and new what the language can do, released every year. And it's because of that yearly cadence, it's always being updated. It maintains its kind of popularity, right? If a language, I'll give you an example. For a long time, the language Java was not updated. I think Oracle bought Java and just kind of sat on its hands for a long time. A lot of old apps were built with Java, obviously different than JavaScript. Okay, but Java, different than JavaScript, don't get the two confused, was not updated for a long time. And it was actually, it was Java as a programming language was losing popularity because it wasn't getting updated. Now, that has changed. Java itself is also getting updated now. Regardless, back to JavaScript. JavaScript is based on what's referred to the ECMAScript standard. And so HTML is kind of the same way. There is a standard that HTML is based on. I can't think of it. But ECMAScript, and so when you kind of hear of the new JavaScript versions, you might hear ECMAScript and then a version number. It's kind of like it's almost like a synonym in a lot of cases, and it's confusing. But the ECMAScript is the standard, and then JavaScript is the implementation of that standard. And so ECMAScript kind of defines the rules. So here you can see ECMAScript defines the rules, the syntax, and how a language should behave. And then JavaScript is the implementation of that. So think of ECMAScript as the blueprint or the recipe, which then other languages can be made from that, right? So JavaScript was made from that. So again, just going through some JavaScript basics here before we get into our first little bit of coding of JavaScript. It was ECMAScript versions, and they have a Wikipedia, and you can kind of see here the different versions. Around 2015, I mentioned this yearly cadence. So now June of every year, this called ECMAScript 6 edition.
What do they use it for, ECMAScript?
ECMAScript, again, ECMAScript defines the standard that JavaScript implements. And so it's just what do people use it for is the question. It's just to say the version of JavaScript.
Oh, okay.
If someone says ECMAScript 7th edition, well, that was the version of JavaScript from June 2016.
Okay, I thought it was like a language or something.
Think of like Windows 7, Windows 10, Windows 11. That's your Windows version. This is just your JavaScript version, essentially. Okay, and we can kind of fast forward all the way to 2025. That's ECMAScript 16th edition, but they just refer to it by its year, thankfully, because you see how it's one off? This is 2015. It's the 6th edition, but they refer to it as ECMAScript 2015.
There's another 6th edition, but it's ECMAScript.
Yeah. So thankfully, they just refer to the versions as the ECMAScript and then the year, and that makes it nice and clean. Okay. So JavaScript is the most well-known implementation of the ECMAScript standard. JavaScript follows the standard. What does it set? The syntax, the data types, objects, and how a language should behave. So JavaScript follows those standards. It additionally introduces the DOM. Remind me what the DOM is. I see it says document object model. Remind me what that means, what that is.
Is it just the, like, what
It's
they
.com?
can see?
What the what?
Isn't it like what the user can see?
Not the user. The DOM, the document object model, is what the browser references your HTML document as. And so if you want to modify your HTML document using JavaScript, then you're going to modify the DOM, is what that's referred to. So the document object model is basically your browser's understanding of your HTML, and then you can modify your HTML by modifying the DOM.
So it's the code basically.
It's the HTML, yes.
HTML part, so like if you spelled something wrong, then on the HTML you would correct that, and then it would translate to the web page.
So the question again, kind of getting into this, is what is the DOM? JavaScript DOM. A lot of times when you see the JavaScript DOM, you see it as a tree, right? Does this ring a bell from last semester?
Yeah, I remember that from the C# class. What did they do?
Yeah. Well, I don't know that this would have been in the C# class. This would have been in the JavaScript class.
It was in both, basically.
Maybe C# and something else, but basically this is the browser's understanding of your HTML.
Yeah.
Right? So if you want to modify the text inside of a link, you have to traverse the DOM to modify that text using JavaScript. It's not super important, but why is it not super important? Because we're going to be using React. In React, you actually don't directly modify the DOM in React. It is important in your foundational understanding of JavaScript, but where we're going, it's not super important. But just as a refresher, the DOM is part of that vanilla JavaScript that is very important. If you want to use JavaScript to update your HTML, you script the DOM, you modify the DOM. Okay, so you got the document object model. which is not part of ECMAScript itself. JavaScript is the only scripting language that natively runs in the browser other than WebAssembly. WebAssembly is a Microsoft technology, but for the longest time, just JavaScript. And that's part of the reason it became so popular.
Did we learn WebAssembly
No,
last year?
I do not believe so.
Okay.
You can also run JavaScript on the server with Node. We're going to learn all about that.
What exactly does Node do?
Node allows you to run JavaScript on the back end on a server.
Okay.
Right now, we've learned how JavaScript is run on the browser, which is the front end. But Node allows you to run JavaScript on the back end.
Okay.
Okay. You know, these browsers like Chrome have JavaScript, what are referred to as engines, to run the JavaScript. And this Chrome's V8 engine, that's just the branding of it. They called it their V8 engine, makes it sound fast because it is. It says it compiles your code into machine code. Machine codes is ones and zeros in a process called just-in-time compilation. This makes JavaScript run very fast. And so, you know, you write JavaScript. That JavaScript is words and for loops and variables and functions and arrays, and all of that JavaScript source code gets compiled into ones and zeros that can be run by that V8 engine and run the JavaScript really fast. JavaScript is the foundational language for a bunch of other things. jQuery, React, Angular, Vue, Node, Express, so on and so forth. Electron builds, I believe Discord itself was built on Electron. Okay. So when it comes to writing JavaScript, there's a couple of ways, just like your external CSS documents, you can link to external JavaScript files, right? You got an HTML page, you want to link it to an external JavaScript, and there's actually a couple different ways that you can link to an external JavaScript. Okay, you can link to it in the head of your HTML document, and I'm going to demonstrate this. Okay, so I'm going to demonstrate a little bit of code. I'm jumping into some demonstration here. All right, so I just paused briefly, and I've navigated to this folder on my computer, which is a GitHub repository, and I'm just going to create a new folder called Labs. And then inside of Labs,
Do you want us to do this or
you don't have to do this, no. This is going to be where I write my demo code. So a new folder called demo code, demo JavaScript code. And I'm just going to open this in here we go. All right, let me kind of zoom in a little bit. Close this window. And I'm going to start with an index dot, I'm going to call it hello world. .htm. Now, I like to use Bootstrap. I'm going to encourage you guys to use Bootstrap just for some basic, you know, formatting of the page. I'm going to go to getbootstrap.com. This is not part of JavaScript necessarily. And then you go to the docs and getting started. So if I go to read the installation docs, okay. On the home page, read the docs. I'm going too fast, I need to slow down. This piece right here has the CSS and the JavaScript. And so I'm going to copy to clipboard, and I'm going to paste this into my HTML document. If I open with live server, actually when I was testing this morning, the CDN for the JavaScript was down. Now this is actually working properly. This morning this wasn't working, so I'm glad this is working this afternoon. I can go to my console and see no errors. It was the weirdest thing. I've never seen it before, but the Bootstrap CDN was down this morning. I could do the same exercise and it wasn't coming up. Nonetheless, okay, so what we're talking about here is linking to an external JavaScript file. So what was the tag that is used to link to an external JavaScript file?
Isn't it href?
That's the attribute. That's the attribute. What's the tag? It's one of these tags on here, on my screen. Which tag is linking to an external JavaScript file?
Script source.
Yeah, we got the script source, right? So the script is the tag, source is the attribute. I'm gonna link to a JavaScript folder. So notice I'm creating a JavaScript folder. You don't have to follow along right now, but let's just talk about where we can write this script tag. You can write it in the head. Now you're gonna see in the head, there's actually a problem with keeping it in the head. So here's the problem with writing a JavaScript file in the head. I want you to imagine a big JavaScript file. And then your browser hits that script tag and it has to download some amount of JavaScript before it continues with the rest of the page. The rest of the page has all your HTML and all your content on it. Okay, so you can kind of see putting the JavaScript in the head. I got the big red X there. It says it pauses the rendering. That's the drawing of the screen. It stops the drawing of the screen while the script is being downloaded. So the user is just kind of like waiting. Okay, so it's not considered like a good performance thing. You don't want to put it in the head without something else. It says then at the end of the body. For a long time, a lot of scripts were going at the end of the body. So for a long time, the solution was putting it at the end of the body. In fact, you can actually see in this example, the script tag is actually at the end of the body, right before that closing body tag. That's where scripts were kept for a long time. That way the browser would draw the page first and then it would download the JavaScript. Okay? Well, somewhere along the line, one of these updates, 2015, 2016, 2017, they introduced this defer attribute, which allows you to put it back in the head. And what it does is it says execution is paused until the DOM has been parsed. So it's not going to allow you to execute your JavaScript until the DOM is completely downloaded and understood. Okay, and it does download the JavaScript immediately. So it's basically, it's not going to slow down the rendering of your page, and the download starts immediately. It just doesn't let you execute the JavaScript until the DOM is understood by the browser. Okay, so this in the head with the defer attribute is the solution that we're going to implement here. So I'm going to link to I'm going to do a script tag. Link is to CSS. Script tag is how we're going to link to our JavaScript. Okay, now this is in the head, but it doesn't have the defer attribute. Remember, we get the best of both worlds kind of thing if we throw this defer attribute on our script tag. Again, that's going to allow the parsing of the page and downloading the file at the same time. So what I'm going to do now is I'm going to create a JavaScript file called hello with a capital world.js. What's that?
What's the stuff that was on the JS file?
Oh, this is nothing. It's gonna go away as soon as I start typing. Okay. So now here's what I'm going to do. I'm going to do a little paragraph with an ID of output. And this is just going to be an empty paragraph. Okay, so right now if I load my page, I've got nothing on my screen. All right, all I'm going to do in my JavaScript is I'm going to target that paragraph. We called it output. How can I target that paragraph? Anybody remember from the JavaScript days? Document dot.
Document ID? No.
Well, you're barking up the right tree.
Document ID.
Remember get element by ID?
Yes. Get element by ID. Yes.
Output dot inner, you could do inner text or inner HTML. Inner text is purely text. HTML allows you to put a tag. But I'm not trying to change a tag, I'm just trying to change some text. Equals hello world.
Don't you have to press a button though?
Save it. Right now, this is going to execute, this JavaScript is going to execute after the DOM is parsed. And so let's see if it puts it in my, there you go, hello world. So I use JavaScript to put this text in here. You know, just as another demonstration, I can put 2025 JavaScript class. Not that here. Okay, open with live server. Okay, so there we go. We've done hello world. Okay,
This is what I never understood.
please.
Is that why would you need a JavaScript if you could just put it in the HTML? That's what I never
No, you do things on clicks and you make things dynamic when you hover things.
So
That's
what-
more real world, but this is just hello world, right? This is just a
yeah.
getting started kind of thing. Okay, but you do raise a good point. It's like, hey, why don't we make this dynamic? In other words, why don't we just wait for a user event, okay, a user event to do something? Okay, so you actually were going where I was going, which is the first programming challenge, okay, which is to do hello world on button click. Okay, so here's what I want you guys to do. I want you guys in your repos, I want you to make a labs folder, and I want your, inside that lab folder, just make it, make a subfolder inside of labs, called whatever you want to call it, refresher programming challenges. And then challenge 1, I want you to say hello world when the user clicks a button. I know you guys, you're going to have to make a button. You're going to have to wire up an event handler. So when you click the button, it runs a function and says hello world. There's your first challenge. What I'm going to do is I'm going to pause it and wait for you guys to solve. So again, first programming challenge, display hello world text in a paragraph tag on a button click. Just for a few more clear instructions, I go ahead and put a folder for your JavaScript. So make a JS folder. And so you want one HTML file that links to that JavaScript folder in the head with the defer attribute. And I'll pause. All right, so how would I solve it? And now that my class all has it solved, let's, again, challenge 1 is hello world on button click. And so what we need is we need to take this line of code. We need to take this line of code and get it on a button click. And this was actually not the code I was showing you guys. Let's go, yeah, hello world. Okay, so here the first thing we need is a button. Now, there's a bunch of HTML buttons. There's a button tag. You can give it a type of button. Bootstrap class of button, button primary. Just makes it a blue button. And this will say click me. Or we'll call it the sucker button. We're gonna, okay, so what we don't have now is an ID. So I'm gonna say ID of button sucker. Okay. So now we have a button that allows the user to click it. And we need an event listener. Get element by ID button sucker dot. There's a bunch of different ways to wire this up. On click equals an anonymous function. And there's different ways of writing this. And you put this line of code in here. Okay, so now we have a button. We have an event handler that says, hey, when you click this button, and there's different ways to wire this up. Let's see if, okay, we have a button click. So, right, that is one implementation of how you could do this. There are many that even going around between the 3 or 4 implementations in the class, mainly around how do you wire up the event. Yeah, the event to the function. In this case, this is what's referred to as an anonymous function, a function without a name. And the event is the click event, the on-click event. So
You can do like E equals that.
yeah, we're going to be doing,
triangle out and then the curly parentheses, right?
yeah, you'll be, yeah, the event. So E represents the event, and then you can get additional information out of E. Okay.
It's a short version.
Okay, so back into theory, and I did kind of just throw you guys in the deep end a little bit there. So if we didn't talk about functions, we didn't talk about anonymous functions, we didn't talk about event listeners. It was like, figure it out, and for the most part, you guys did, so that's good. Even though I just kind of threw you in the deep end a little bit. So you know, we're going to go back a little bit more and hit some more of the basics. This one, we're going to talk about variables. And I'll make another file called variables.js. So a JavaScript file and an HTML file. The HTML file, instead of this saying bootstrap demo, I'll say hello world on click, something like that. And I'm just going to copy this template over because I know this is my bootstrap. I'm going to paste it into my variables.htm. And instead of linking to hello world.js, I'm going to link to variables.js. Anybody remember the key word to define a variable in JavaScript? Let. There's actually 3 keywords.
But let was like all of it. Const was like for a specific one, and then
Yeah.
I didn't really use var that much.
Yeah, you shouldn't use var. That's exactly right. So the general idea is this. You use let and const. Let is for variables where the data can vary, like the data can change. Const is the idea is that you assign it one time, you put data into it once, and you cannot change it. Okay, and you can see here the old way, pre-2015, of declaring variables was just with the keyword var. So if you see the keyword var, it's kind of one of 2 things. Number 1, it's old JavaScript, or number 2, it's a developer who hasn't updated their JavaScript knowledge in 10 years. Okay, So if you come across a new developer, you know, if you're ever like interviewing a potential developer and they're coding their JavaScript with var, like that's a tell. Like they haven't updated themselves in a while. Okay, so you don't want to use var, and you don't want to, unless, you know, I don't know of a scenario where you would write new JavaScript using the old keyword, because there's a bunch of problems with it. Okay, so that's it. You use constant if the data doesn't change. You use let if the data does change. Okay, so back into the theory a little bit. A variable, the technical definition, look up variable in the programming definition book. A variable is a named storage location for your computer's RAM. That scared me when I was like a beginner programmer. I was like, oh man, if I define a bunch of variables, it's going to use up a bunch of RAM. And I was wrong, because a variable is a minuscule, very small, you know, amount of RAM compared to our laptops have gigabytes and gigabytes, and these are simply bytes of storage. Okay, so don't be afraid, like I was as a beginner programmer, to create variables, because very small. Like if you listen to Bill Gates talk about when he was a beginner programmer, you were really concerned about how much memory, how much RAM a variable would take. Okay, and today in modern programming, there are some devices, like if you ever, and I've never done it, but I understand, like if you're writing software for like a remote control, like a smart remote, you know, your Google, like I got my Google TV and I got a smart remote. Okay, maybe there's limited RAM on a small remote kind of thing. So there are scenarios today where you got to be really conscious of how much memory your variables take. But by and large in this class, you don't have to worry about it. Okay. I'm jumping ahead. JavaScript is dynamically typed. What does that mean? That means that the data type is selected for you by that JavaScript engine. Remember that V8 engine that Google put into their browser, right? That runs the JavaScript. That JavaScript engine determines the data type. Different than C#, right? C# was strictly typed. All of your variables, you said this is a string, this is an int, this is a float, this is a double. Okay, so there's strictly typed languages, which you know exactly the data that's going in. And then there's dynamically typed, where it just kind of figures it out for you. Okay, the
AI?
not AI, it's just the software built into the browser. Okay.
JavaScript is a dynamically typed language, while C# is a statically typed
Oh my
language.
goodness.
You didn't even say, hey
I don't,
Siri.
yeah, it just does that from time to time. So there's no type declarations. You're not saying this is an int, this is a double. You're just saying let or const. It allows you to change. Like you got a variable, and it could hold a string, and then it can hold an int, and then it can hold a double. Okay, so the type flexibility, the data type can change what that variable can store. There can be runtime errors. Like if you try and convert something to a data type that doesn't work, that can actually crash at runtime. You know, your JavaScript script can crash. It also can lead to reduced clarity around the data that a variable holds. Sometimes you're just looking at the variable name. Like I want you to imagine you're pulling in data from the internet, and the internet's a wild place. There's all sorts of data, and you store it in, you store this data in a variable. You might not have a clear understanding of the structure of that data. You don't know if it's a string, a double, a float, an array, an object. You might not know what's in that variable. Okay, so because JavaScript is so popular, this is how vanilla JavaScript works. But there are enough developers that wanted what's called type safety in JavaScript, and that's what TypeScript is. So TypeScript, and we'll get into it, is a superset of JavaScript that is JavaScript with data types, okay, that are strict data types. They're not implicit, okay? Yes?
What do you mean by vanilla JavaScript?
Vanilla JavaScript is what we're doing here,
Okay.
okay? There are languages built on top of that, frameworks that are built on top of that, like jQuery or React,
Okay.
okay, that are built on top of vanilla JavaScript.
Okay.
Okay. So let's just do a little code here. So I've got my sucker button here called the ID of sucker, and what I'm going to add to this is a label for txt user input, enter something. And then I'm going to have an input type of text. Now I'm going to have my bootstrap class. Don't forget your equal sign. My bootstrap class of form label. And my bootstrap class of form control.
Bootstrap, there's some use to it.
Text. Okay, let's talk about a couple of things here. Let's talk about the HTML.
You have a red.
Double quote.
Good catch, thank you. Okay, so I have a label and it is for my text box. That means if you click on the label, it focuses the text box. The cursor will be blinking in the text box. This is considered for accessibility purposes, right? There are some people with shaky hands. They have a hard time clicking a text box. You click the text next to the text box, it focuses the text box. So this is considered for accessibility. We have a text box. It's styled with Bootstrap, so it's going to go across the whole page because it's going to be mobile responsive, and it has an ID of user input. And I'm going to make a by ID. I'm going to target my sucker button. Here's another syntax. Besides my on click, we can do add event listener for the click event. Okay. This is just another syntax for wiring up a click event to a button click. Okay, it's a similar kind of anonymous function. I'm going to declare my variable. I said let is how I'm going to declare my variable. Now first off, there's two parts. Declare a variable, and then there is the assigning a value to the variable. Okay, so declaring is when you give it the keyword let and the identifier. Assigning is what? What is the symbol to assign? The assignment operator is the...
Like A, X, B, like that kind of thing?
Nope. What is the symbol for assignment? Yes.
Symbol.
The equal sign. That's all.
Oh,
That's all I'm looking for. The equal sign is how we assign a value to the variable. And then we're going to do so by document get element by ID,
And that's why.
text user input dot value. Ooh. You can do inner text. This is a, I don't know why it's not happy with dot value. That should work. Okay. So we declare a variable, we assign that variable. What's on the right-hand side here is what's going into the variable. What's on the left-hand side is what is changing. This is the data that's changing. The variable is user input, that's changing to the value that's on the right-hand side. Okay, then what I'm going to do, I've got my output paragraph. So I'm going to do this. I'm going to say document. This is going to be my output. Output the value and the data type of the variable. Document get element by ID. I'm targeting the output paragraph dot inner text equals. Now check this out. You guys see these symbols right here? Everyone look at my screen, please. Those are not single quotes. Those are backticks. The backtick is above the tab key. Okay? This allows you to do what's called string interpolation. Okay? Do you guys remember the word concatenation? String concatenation is where you're like adding values and together with strings. You're like adding to strings. Interpolation is basically where you mix strings and variables together in one string. So check this out. So here's the syntax. This is a string. You entered, then you do a $, curly brackets. Inside the $, curlies, that's where you can put a variable. So inside of the backticks, you could put strings and you can mix in variables, and the variables just go inside these $ with curly braces. So what's our variable name? It is user input. And \n is a new line. It's JavaScript data type is, and there is a $. There's a type of operator, which looks like this, type of user input. Let me get this kind of visible for you to see. Close my curly, close my backtick, semicolon. Let me see if I do that.
And that equals like a new line, right?
I think that's going to work. If it breaks, we'll see here. So what am I doing? I got a variable declared. I'm putting some value into the variable. Then I'm spitting it back on the screen. I'm saying, hey, this is your variable. And there's a data type there, which is this type of basically reads the data type. What is the data type of this variable? Okay, so let's see what breaks. And I'm going to say Evan, my name, sucker button. You entered Evan. Its JavaScript data type is string. Okay, cool. Went into a variable, and it understands that the data type is a string. Now it's reading out of a text box, right? So if I type in the number 3, you would kind of think, what do you think that, do you think that's data type? What would it be? Let's go back to our data types. I didn't really talk about the data types. Here's the data types. Let me highlight the important ones. Number, there's no int and double and float in JavaScript. They just have number. If it's a really big number, they have something called big int. I don't really have to deal with that because they're just giant numbers. Okay? Like, I don't know how many atoms are there in the universe. Like, giant numbers. Okay? So there's the number data type. There's the string data type. There's null, which is an empty value. There's Boolean, true or false. That's basically it. That's the ones that you have to be concerned with. So again, our data types that we just kind of listed, you know, we have the generic number, Boolean, string, and null. Thank you. Null.
What's null?
Null is an empty value.
Okay.
It represents emptiness.
So then why do we have it?
Because if there's nothing in something, you test for null.
Okay.
You see if something is empty.
Oh, so like when you have like that red dot next to something, then that's what it's for. Like when you like sign up for something and it has like a red dot next to it and you have to put something in it, but if you don't,
That's
then
just an indicator.
Yeah.
yeah.
I mean, well, you could, for example, say there's some data in a variable and you want to empty that out. Like you don't want that data there anymore. You could set the variable equal to null. That kind of like deletes the data that's in there.
Oh, okay.
Okay. Now, these data types are referred to as primitive data types. There are some other data types here that we're going to talk about, but these are the primitive data types. So these are the common ones. Why am I talking about this? Let's save this. If I go back to my code demo right now. If I enter the number 3, what data type would you assume? You would assume number because, well, 3 is a number. But if I click on the sucker button, it says, 3 is actually a string. Why?
Input.
Yeah, it's an input type of text. It's an input type of text. Anything you put into a text box is automatically a string. Okay? So if we want to code,
For a number.
what if I do an empty string? You entered nothing, its data type is string. Which is technically still true. You entered nothing and is essentially what's called an empty string. I could put in true. It says you entered true and its data type is a string. Okay, so I'm just going to fix this real quick with some if statements. Say, hey, if they put in the word true, convert it to a Boolean true. If they put in a number, make it a number. Okay, so here I'm just going to do something like if user input dot trim. What do you think trim would do?
It trims the excess.
That's right. So if it's empty, I'm going to say user input equals, you didn't enter anything. Okay, so I'm going to start with a simple if statement like that. So now it says you didn't enter anything. And that's okay, that's already a little bit better. Maybe if you return out of it, then it never gets down here. But okay, else if I'll talk about this line. Okay, so this converts user input into a number. Well, isNan is not a number. So is not a number, and then you reverse that. So this basically tests to see if you can convert it to a number. This is a really, you got to say isNan function, and then flip that logic to basically say, if you can convert this to a number, then let's update user input, converting that into a number. So the variable user input is assigned the string user input converted to a number. Save that, refresh it. Now if I put in 3, it says you entered 3, its data type is number. Okay? Again, because I'm just kind of, I'm showing you that like the data types are happening automatically, but you can change them. You can forcefully change them. Not that you have to do this all that often, but I'm just showing you the different data types and the way to convert. Here's a couple else ifs. If you can convert it to the lowercase true, then mark it as a Boolean true, Boolean false. What's the triple equal sign versus the double equal sign?
Does that mean like it's absolute?
Yeah, it's actually the value is the same and the data type is equal. So a double equal sign will only test the value. A triple tests the value and the data type. So, you know, the data type is a string on the right and a string on the left. So the data type will match and the value. So if I go false, data type is Boolean, true, we get that. I put in anything else, you get a data type of string, you put that in, you put that in. All right, so back a little bit more, let's declare a constant.
That needs to be put outside the function, right?
Well, it doesn't need to, but I did for a certain reason. This is a constant variable that has scope within this file, aka global scope. What does scope mean?
It means it's the entire thing. It's the entire code.
What does the scope of a variable mean?
It's where you can use it.
It's where the variable is usable. So to say that this variable is usable in this entire file because it's not declared inside of this function.
So you can use that anywhere within.
Anywhere within the entire file.
Okay.
Anywhere within variables.js. This let variable has local scope, meaning it's only accessed within the function. It's only available within the function. So we declared the variable in the function, so it's accessible in the function. We declared this variable outside of the function, so it's only available, it's available basically in the whole file. And I'm second guessing whether this actually is a true definition of global scope. Global scope to me means it's even accessible to multiple files. So I'm even questioning my own definition here, but nonetheless, it is within the file, whether you call that global scope or not. It's available within the file. This one is local scope. And then there's one more. If I were to make a variable down here, I'm going to say let dummy variable equals 5. This is what you often call block scope. And you can see only available within this block of code. So this is this if statement right here. So if I tried dummy variable and I tried to access dummy variable out here, you could see this causes an error. And I don't know when that causes an error. Let's 1, 2, 3, click on my sucker button. It's apparently not breaking. It's not a breaking error because I didn't really go to
You didn't really
I didn't really use it. So let's just go here And let's just try and throw in dummy variable here. You know, when you don't want things to break, there we go. Dummy variable is not defined. Okay, so again, I'm doing a little bit more of just going back and forth here. Global scope is declared outside a function, so I had that right. Local scope declared inside of a function. Block scope declared inside of a control structure, such as a for loop or a conditional if statement. So the scope, meaning the parts of the program that the variable is accessible in. You notice I'm using what's called camel casing. Camel casing for my variables. So you use camel casing when the variable could theoretically change, especially if it holds an object, an array, or a function. We'll talk about variables holding functions. That's different for sure. And then you use uppercase snake case for your constants. Semicolons in JavaScript land are optional but recommended. It helps people, like in the English language, know where you put the period so you know where the sentences end. You put the semicolons at the end of JavaScript statements so you know where the statement ends. So they are recommended. We can go through the basically never use var. Let has certain advantages. Const is basically the same, but it can't be reassigned. They both are block scope, so they're just accessible inside the block that they're declared. This is why this is confusing, because it does not override the window object, meaning let doesn't automatically become accessible outside of the file. The variables do not become accessible outside the file. Believe it or not, if you used the keyword var, that variable would be accessible outside the file in what's referred to as the window object. And that can actually cause conflicts. You can have multiple variables in different files with the same name and conflicting variable names. So this kind of locks it down a little bit better. Challenge number 2. This is very similar to what I just did. This program, I called it Guess the Secret Value. Create a simple web page where the user tries to guess a secret value. Use const, let, and block scope as demonstrated in variables.js. The secret value can be a number, a string, or a Boolean. Give feedback based on the user's input and display it in display its JavaScript data type. So you declare a value, a secret value, using a const up at the top of your script. Create an input box and a button for the user to enter their guess. On a button click, check the user's input. If the input matches a secret value, consider its type and value. Display correct, you guess the secret value. If it's empty, display please enter a guess. If it's not correct, say try again. Always display the data type of the user's input. Use let for variables inside of your event handler and use block scope for temporary variables. So here's what I'm going to do. I'm going to put my code over here. I'm going to put the problem over there. Okay, because these two things are very similar. And you can probably reference my code to help you get started. Let's see if I can get all of this on the screen at once. Can you guys read that okay? Yep. So there's a challenge. There's some code that'll help you. I will pause. Okay, so let's take a look at a solution. Again, your solution does not have to match. This is a solution. One of my current students has offered to share his screen, so I'm going to hop on Discord and Ryan is sharing his stream, and I'll talk if Ryan, you don't just mind driving, unless you wanna talk it out. I don't know the microphone. Okay, you're good. All right. So I can kind of see on line 1, you've got the secret with the capital S on sucker. And so we have line 2, we have a event listener on a button click. We read a value from the form, from the text control into a variable. Line 6 checks for an empty string. Line 9 checks to see if it's a number. If it does, it converts the line 10 converts the user input into a number. So line 10 converts the data type. Line 13 converts to a Boolean. Line 16 converts it to a Boolean true or false, right? And then line 19, we have a new variable called output string. So then we have to test to see, okay, so like that first if statement converted the data types. And then that second if else block checks to see if it is a matching value. And so you say, hey, if it's not equal to, if the user's input is not equal to the secret, you did not enter the secret word. Otherwise, if it does equal the secret, you guess the secret word. And then line 28 is your output. It outputs the output string as well as the data type that you converted in the first control structure, the if else if block. Okay, so let's go ahead and run it, and let's enter in the capital sucker. You know what? Your stream, you're not showing your entire.
I can change it.
Okay, cool. I'm only seeing Visual Studio. There we go. So here's his screen. Let's just show the capital sucker. You guess the secret word, data type of string, put in a number there. Okay, put in a true. But at least you're getting the data types are changing, so that's all good. Go back to your code, change your secret to something else, another data type. Okay, we're still looking at your browser, so that's okay. Just go ahead and change the code. Change the secret to a true, is what she said he was going to do. Okay. So kind of two blocks of if-else blocks. One if-else block converted the data type. The second if-else block. Anyone do it any differently? Or that kind of is where people landed? Some solution similar to that? Yep. Awesome. Thank you, Ryan. Okay. JavaScript, onto a little bit more theory here. And this is on falsy and truthy. JavaScript is unique in that when you have an if statement, you don't need to say if the variable double equals 1 all the time. You can say if something, it's basically your if statements can have these categories in one of two buckets, right? So one bucket is the falsy bucket and one bucket is the truthy bucket. So you don't have to do like a hard if this variable equals something. It can be kind of true, right? If it's considered truthy, and therefore your if statement would evaluate to true, right? So it doesn't have to be like a hard truth, if you will. It just has to be truthy, kind of true. So like if you could say, if, and then put a variable that equals the number 1, and that would evaluate to true, right? If your variable held a negative value, that would evaluate to true. So let's wire up something real simple here. and kind of demonstrate. Again, the point of this is that there's two buckets. There's a falsy bucket. There's a truthy bucket. True, positive and negative numbers, arrays, and objects are all considered truthy. False, 0, negative 0, interestingly enough. Empty string, null, undefined, and not a number. All of those count as falsy and would evaluate to false. So truthy bucket, falsy bucket. And so let's show how you can wire this up. I'm going to make a new file here called falsy truthy.js. Let data equals 1. If data, we're just going to say truthy. So if data evaluates, just to show you that you don't, this is different in JavaScript, right? In C#, you don't have falsy and truthy, right? You could just test a variable, and that variable will evaluate true or false. The only variable that works that way in C# would be a Boolean variable. So here I've just got a empty HTML page. I'm linking to my falsy truthy. When this basically will run, because I'm telling it to run on a defer, this should run on page load essentially after the DOM is loaded. And if I go to console, I could see the output of truthy. Right? So this is just different, being that you don't have to have like a Boolean expression in here. You could just put a variable. That variable can hold a number, an object. You know, I could do something like an object here. Okay, so this is a JavaScript object that has one property of the letter A, and its value is the letter 1. The point is, this object should also evaluate to truthy, right? Because objects evaluate to truthy. If I say the data is null,
It has nothing in it.
it has nothing in it. Why does that not do anything? We need an else block. Else, we say falsy. If I refresh, we could see that a null value evaluates as falsy. All right, let's expand on this. Let's expand on this. I have an array of values. Everything from false, a numeric 0, empty string, null, undefined, not a number, nan. A string of hello, the number 1, an empty array, an empty object, and a string number of 0. I'm looping through my values array. I'm looping using a for each function in JavaScript. So I'm looping over each one of the values one at a time and calling each value val, right? So the first time through the loop, false, val is equal to false. The next time, val is equal to 0. The next iteration, val is equal to an empty string. The next iteration, val is equal to null. You guys see how this variable val is changing every iteration of the loop. Okay? And then I'm saying if val is truthy or falsy, put it in the inner HTML of my paragraph. I need a paragraph here, P ID of output, so that I can spit out the output of all my for each loop. You can see the value false is falsy, 0 is falsy, empty string is falsy, null is falsy, not a number comes back as undefined, but not a number is falsy, null is also falsy. And then you get the string is truthy, 1 is truthy, array object is truthy, and the string value of 0 is truthy. So the numeric 0 is falsy, which that one throws me off the most. The number 0, because a lot of times like a 0 is a valid answer. Like where does that get you in trouble? Well, like on a test score. Your test could be a 0. That is a valid test score. So to say 0 is falsy, that's the one that screws me up the most. Everything else I would say is semi-logical or intuitive a little bit. But 0 is the one. Numeric 0 is the one where a lot of times that's like a valid score, you know, or a valid number in many cases. Okay, do you guys remember this from JavaScript at all? Maybe a little bit, these falsy and truthy buckets?
I don't think we ever did those falsy and true.
We didn't really get into that.
Yeah.
Anyone? Do you guys remember them? Yay, nay, nay?
It's not sounding familiar.
Okay, that's why we're reviewing it. That's why we're reviewing it. Okay, this one's pretty similar, right? Is your input truthy or falsy? Create a web page with a text box and a button. When the user enters the value and clicks the button, your code should determine if it's truthy or falsy. And also display the data type of the input. So use an if statement to check if it's truthy or falsy. Display message, your input is truthy, and the data type is whatever it is. The data type is a number, or the data type is a string. Programming challenge number 3. So I'll pull this up over here. I'll pull this up. Not that one. This one. Over here. I'll zoom out. Kind of hard to see, but there you go. You can scroll in if you need to see my screen. There's the programming challenge. There's a little bit of code to help you out, and I will pause while you do challenge 3. Okay, current student offered his solution, so let's go ahead and take a look. Walking through, this looks like you combined the last two, because I see the secret up at the top. But we got a button event listener, and falsy result on line 8 says this is not a falsy value. We get the user input on line 10. If it's empty, we just say, hey, an empty string, this is a falsy value. We update the data type on line 19, line 24, line 28, we're updating data types. If it's null, we assign it to null, undefined, undefined, not a number. Okay, if it equals the secret. If not user input.
Because I had originally set it up backwards.
Uh-huh. All right, go ahead and run it. So you did some manual testing there, it looks like. Is that what you did? You just did manual testing?
Originally, I had it an array with all the possible ones.
So let's just look at the value of null. Sorry, so let's just walk through in the case of null. Go back to your code for me. So it's a string null. So you assign user input to null. So user input is null. And then you say, that's why you reverse it.
Mm-hmm.
So if user input is null, then you say not, this is a falsy value. And then if it's truthy, let's see a truthy one. That makes sense. Well, what about the number 1? It says this is not a falsy value. So let's walk through that case. The number of 1, so back to the code. So you convert it to a number. Scroll up for me on line 19. 1 is converted to a number. And then you scroll down. Oh, up at the top it says this is a truthy value.
Yeah.
Yeah,
that's just.
so on line 8 you assume truthy. You assume truthy at first. Say not a falsy value. In other words, truthy. Okay. Okay. Anyone else care to offer a yeah, please. So that was one. Quinn offered. You know how to screen share on Discord?
Yeah. I'll share my whole screen.
No problem. Okay. So we got a function called getValue.
After everything.
Okay, Quinn, you offer to explain it?
Yeah,
Sure.
explain it. I mean, it's not too dissimilar to what was just shown, because I didn't want to use an array of all falsy values, because it kind of felt a little like cheating almost, when it's really not. But gets the user input, its value, then it checks to see, if the user input is equal to nothing, like makes sure that there's actually an input in there. And first, it then checks if it's a number, and if it is, then it assigns a type, and so on and so on. The only big difference between our solution is that it uses the Boolean constructor to then check if it's true or false.
Okay.
So it's,
So yeah, you say if Boolean value to check, and that will evaluate to a truthy or falsy.
yep.
Yeah, on line 38. Could you not just do if value to check?
Oh yeah, I guess you could. Right?
Yeah,
The
if
Boolean
value to
component.
check. You just put that directly in.
Yeah, you're right.
All right, let's save it and run it and see how it runs. Unless I just broke it.
No, that's just chill. Like 0, falsy,
So it's
truthy,
Yep.
false. Oops, yeah. Alright, respawn just with that.
okay.
You also have that
Awesome. Thank you, Quinn.
somebody for us to
All right, on to a little bit more
falsy result.
theory, and then one last challenge for the day.
In your case.
Okay, the last chunk of theory is high-level theory. I mean, I'm just going to list them, and then we're going to go into the code, right? So when you have an array is a structure that stores a bunch of data, right? In C# you have like an array of strings or an array of ints or an array of Boolean. But in JavaScript, your array can hold all sorts of things. It can hold numbers and Booleans, and it can hold different data types. Okay? When you have an array, it's very common to iterate over that array and like look for things in the array, or operate on that data that's in the array. So there's actually 6 loops that are in JavaScript that will allow you to loop over an array. Very similar to C#. You've got while, do while, and for loops. While is a pre-test, a do while is a post-test loop. A for is often called a count-controlled loop because you can like look at a for loop and very many, you can see, okay, it's starting at 1, while I is less than 100, that's going to iterate 100 times. So it's often called a count-controlled loop. There's a for in loop that's a little shorthand in JavaScript. There's a for of loop. Just, one works with arrays, the other one works with objects. So I'll cover those. And then there's the array for each. That for each loop is literally what I just coded here, right? So I showed you a for each loop on an array called values already. So I've already demonstrated number 6 a little bit, okay, without explaining it. I just demoed it, right? So quick demonstration of each one of these loops, and then I will give you a challenge. So let me kind of go full screen here. Let me zoom in for you. Let me close that down. I'm going to make a new array looping.htm. And array looping.js. And my HTML, let me just link to my array looping.js. I've got a paragraph for my output. So that's going to be my output paragraph. Let me define an array. Okay, so I've got 3 elements in my array. So with a while loop, okay, so we need to define let I equal 0 while I is less than array.length. The length of the array, that's correct. Document get element by ID.
And 0 is like the cat, like the first number, first thing, right?
That's right. Okay, so what am I doing here? I'm targeting my paragraph output. I don't want the inner HTML. Inner text plus equals. So I'm adding on, I'm appending to, I'm not overriding. If I were to just do equals, this would loop through. That paragraph would say cat, then it would replace it with dog, then it would replace it with the word bat. You'd only see the word bat at the end, because every time through the loop, it's just replacing what's in the paragraph. If I'm reassigning, to append it, you do plus equals. That appends cat, then it appends dog, then it appends bat. Okay, so with the while loop, append the inner text. There's our while loop. Open with live server. Something didn't work. As I notice here, I've got this probably infinite loop. Why? Whoops. I forgot to increment I plus plus. Forgot to change I. I always was 0, infinite loop. I've been coding for 20 years. I still do stupid infinite loops. Now, that's not exactly what I wanted. So, because this is inner text, I can't have that BR tag, inner HTML. Now, it actually does a line break. That makes sense. Okay, that is a while loop. Let's comment that out with a do while loop. Let I equal 0. Do while I is less than array dot length. And here, very much the same thing as before, except for you're guaranteed to do this while loop once. This you're not guaranteed to do it all. If this condition, this code will run guaranteed once, and then the condition is tested. So same output, not that impressive of an output, but there is your do while. So there's your while, there's your do while. With a for loop. And the for loop is a beautiful thing. You can say let I equal to 0, I less than arr.length, I++, put it all together in one place. Paragraph output, enter HTML, plus equals. For loop is nice when you know the number of iterations. You can count. This starts at 0 while it's less than 3. So 0, 1, and 2, that's 3 iterations. Cat, dog, bat. The next one is new in the JavaScript world. I don't know how new it is. We'll call it 10 years old. This is a for in loop. Okay, now we haven't talked much about objects. So I'm going to say
We didn't learn any of that.
const, we will, person equals, and we'll let Copilot just make my person object. Okay, so here's an object. It's got a first name property, a last name, and an age. So this person, in JavaScript, when you see the curlies, always think object. When you see the brackets, always think array, right? So brackets, array, curlies, always going to be object. For const property in person, so we're looping over person, we're looping over each property. The first property is first name, L name, and age. So this will append the person sub for F name. Person sub F name will give you the value of John. Person sub L name, which is what's in the brackets there, will give you Doe. Person sub age will give you
Their age.
25. Back to the loop. There you go, John Doe 25. So this is called the for in loop. For in loops are used to loop over properties of an object.
And you use those for search engines, right?
They're used for all sorts of things. I'm sure they're used in search engines, yes. The next is for of. You can see the keyword for, and then you see the word in. Thus, the for in. For of loops are used with arrays. And so let's bring our array back, called ARR. For const item of array. Spit out the item. So for of, for in. Let me comment out this code. Demonstrate the for of. Okay, so there you go, for of, spitting them all out. And last but not least, the one that we already demonstrated, the array for each method. ARR.for each item, for each item. Let's do this. Document enter HTML plus equals item. line break. Very similar to what we did just a second ago. All right, those are the 6 ways to loop through an array. They're all very similar, but slightly different. Last challenge is a searching algorithm. Yeah, I'm going to leave you with this one. Programming challenge, create a searching algorithm. Objective, write a program that asks a user to enter a username in the text box. Use a loop to search for that username in an array. So the array of your usernames, Ape Lincoln, the notorious PIG, and Beyonce. Display a message if the username is found or not. Make the search case insensitive. So a lowercase a and a lowercase l would also return that username is found. And I thought, why not make some silly, punny type, I don't even know, no, it's not, whatever. Silly usernames. There's your challenge. There's the challenge on that. Let's put my code on this side. Before I pause, I'll leave it about here.
All of them? Or just
No, you just do one. Just do one. And yeah, we'll come back after some of you have solved. All right, let's walk through one of our student solutions. And so this is the programming challenge where we're looping over an array. So the array is of usernames. And on line 3, we have a searched username variable. We have a button click. We are reading. All right, line 6, we get the input from the HTML. Right? Remember that whole scripting the DOM thing? This is like reading from the DOM, document get element by ID. Literally the word document, object, model. We're looping over our array, our usernames.length. And then we have a conditional if statement. If the array sub-0, 2 lowercase, triple equals what the user searched for, then we update saying the user found, and we break out of our function. Otherwise, we continually update the output inner text to say user not found. And so this is one solution, and you want to go ahead and demonstrate our search feature. And so whether the user is found, and this is case insensitive, right, versus the capital letter A. And then give an example of a name not found, of course. And then maybe just one other value in the loop just to demonstrate that. There we go. And yeah, there is a valid solution for that programming challenge. Thank you, Brody. And let's hop on back to the lecture. Okay, where we left off yesterday, we talked about different ways to loop through an array, and that left us on this topic of functions. So if you guys want to go ahead and hop on my screen share, can everyone see my screen? Okay, same format as yesterday. A little bit of theory, all the theories in this document that you guys have access to this document, followed by a little bit of coding demonstration, followed by programming challenge. Let me open up my Visual Studio folder from yesterday. Get VS Code back onto my screen, ready to go. These are the JavaScript files and the HTML files from yesterday. So we got that ready to go. Functions in JavaScript are quite a bit different than functions in other languages. It is because of this. If you kind of go back and watch this interview with the developer of JavaScript, they talk a lot about functions being treated as what he refers to as first-class citizens. I can't really figure out what that means. I mean, there's a technical definition of what that means, but I mean, basically, they're important. They're highly important. I think that's not the technical definition, but to me, what that means is like functions in JavaScript are more important than maybe functions in other languages. And so what does the technical definition of it mean though? Right? So functions are important. Okay, that's probably bad on my part because functions are important in every languages, right? But first-class citizens, well, that would be better than second-class citizens.
They should just.
Yeah, maybe they need to give it a better name. But what does it mean to be a first-class citizen? Okay, this implies several key characteristics. So this is the more technical definition of a first-class citizen. And right here, I'm highlighting a piece here that already you're going to see, if you start to think about what this means, functions can be assigned to variables. Did you guys realize that? If you stop and think about it? A couple people nod their head yes. Well, what do you typically assign to variables?
Information.
Yeah, just data, right? So like, let value equals 42. And so I will tell you the first time I came across this, and I'll show you a coding demonstration very quickly, what it means for a function to be assigned to a variable. But that's already something that's different. Functions can also have properties. That's different. So an object has properties, right? But functions can have it calls it object properties. And so that's different. Or functions can have array elements. And so these three things right here is kind of like, that's a lot different than your standard function. Okay? And so I think we need to get into some coding demo, like what does that actually look like, and we will. There's a term here, higher order functions, okay, which means functions can be passed as arguments to other functions. We need to talk a little bit about inputs and outputs of functions, but a function can be passed as an argument. That's different than many different, many languages. If you've ever studied like Java, C#, you're not doing this with your functions in traditional Java, traditional C#. Maybe someday those languages evolve to be more like JavaScript. I don't know. But like you're not doing this stuff in C#. This is specifically features in JavaScript that exist that don't exist in other languages. Just like you can pass a function into another function, a function can return a function. So functions can be returned as values from other functions, and functions can have their own properties. We kind of talked about that. Functions can have their own properties and methods. Okay, so all right. What's the takeaway from all this? Functions are just different in JavaScript. Okay, they're different than they are in C#. They're different than they are in C++ and many other languages. Languages, when they classify functions as first-class citizens, they mean they can do all these additional things with the functions. Okay, and we really need to get into some coding demonstration to see these things in action. Okay, we will demonstrate functions being assigned to variables. We will demonstrate higher order functions, right, to give you some examples of these things. But here's some more function basics, right? Anytime you have a function, a block of code that performs a task, it could take optional inputs. So any function, it doesn't have to take inputs, but it can have 0 or many inputs. It can have one optional output, right? Functions don't have to have outputs. They're optional. So as far as the inputs to a function, it's 0 to many. As far as the output, it's 0 or 1.
What does that mean?
The keyword return, if you remember the keyword return in a function, that keyword return is optional.
Okay.
You don't have to return any data.
Okay.
Okay? In object-oriented programming, you had these same concepts. These concepts did exist in C#. You might remember hearing these terms, passing by reference and passing by value. Nod your head if you vaguely remember these terms. Yes? No? Two people nod their head yes. One's, well, passing by value and passing by reference. Okay, safe to say, data can be sent from out of the function into the function. Okay, so imagine a variable, and the variable is being passed from out of the function into the function. Okay?
Aren't those just like constant lets, to be honest?
Yes. Yeah. So like a let, for example. Okay, a variable passed from one point in the program into the function. Okay? That function has an input variable. And I almost need to demonstrate it. But it's very much like a copy and a paste. If the data is passed, a copy of that data is passed into the function when it is a primitive variable. So it says here, when primitive variables, that's known as passing by value, that makes a copy of the data. And so you essentially have two copies of the data. Changing one copy does not change another copy. So the primitive data types are string, numbers, booleans, null, undefined, and symbol. These are a lot of the data types that we talked about yesterday. Okay, so some data types pass by value. Other data types pass by what's called reference. And reference is not a copy of the data. A reference is like passing the data itself, and now you have two identifiers that reference the same memory storage location, and therefore updating one variable is like updating both. It's kind of like a cut and a paste. You have two identifiers that reference the same data. Okay, reference data types are object, array, function, and date. Okay, so these concepts do exist in object-oriented programming. I remember like when I was a brand new programming teacher, and I was teaching some of these concepts for the first time, and I had a student go out onto the job market, interview for a job, and on the interview they asked, can you explain the difference of passing by value and passing by reference? Okay, now this is this was an interview from 2009 or something like that, a long time ago. But these are just some very normal concepts. Whereas first-class citizens, to me, those are not normal concepts. This is something that was fairly unique in my learning of JavaScript. Have you guys studied any other languages where functions are treated as first-class citizens? Have you seen that before? I hadn't seen that before in the languages I've studied.
We only studied HTML, JavaScript, and C#.
At Rankin, I just didn't know outside of Rankin if you had seen anything.
Well, where are other ones where they're...
You know what other language? Let's ask what other languages, what programming languages have functions as first-class citizens? Not cities, citizens. So here's a list, and there, it's not a short list, it's a pretty good list. Okay. So JavaScript, Python, two of the more popular ones. Go, Ruby. So that's good.
What do you use Ruby for?
Now, it does list C# eventually. While traditionally, object-oriented C# has incorporated some features like link. So it's the same way with Lambda. So that's good to update my language because, yeah, there are some features that it treats functions as first-class citizens in C#. Regardless, okay, back to function basics, okay? When it comes to functions, you are either declaring a function many times, and then once you've made the function, you've declared the function, then you call the function, right? So you got to declare it first, then you have to call it. Create the function, call the function. There's kind of three syntaxes to declare functions. And we're going to cover how to do that. There's what's called the function declaration, something called the function expression, and there's arrow functions. And within arrow functions themselves, there's a lot of different syntaxes for creating arrow functions. Now, we'll see here an arrow function is a compact alternative to function expressions. So we're going to learn a function expression, and then we're going to learn arrow functions, which is a compact syntax for function expressions, and then we're going to get into our next challenge. Let's pull up some code. Can everyone see my screen okay? Okay, as we've been doing, create your HTML. Just as a reminder, you know, I got the question yesterday, does it need to be HTML or can it be HTML? The answer is yes. Most web servers understand the difference with the 3 file extension or the 4. In the old days, if you wanted to be safe, you always had to have the 3-letter extensions. That's why I always do HTML, because a lot of web servers back in the day, if you had that 4th letter on there on your file extension, it would cause some issues. Regardless, I'm going to copy my Bootstrap template into my functions.html. I'm going to change the title to functions. I'm going to link to my functions.js. that I have to create. Here's functions.js. And let's discuss some various ways to declare functions. And there was a 4th way that I didn't include in this lecture, but here's 3 ways to declare functions, guys. We're going to go over some function basics. Let's get into this. So the first one is called a function declaration. And this is the most common syntax that you have seen. Okay. We're declaring a function with the keyword function. How many inputs does this function take? 2 inputs. How many outputs does it have? 1 output, right? Pretty basic function. How do we call that function? Yeah, there's a lot of ways to call it. Let's call it on button click. Here we have a button called sucker button. And let's say on click, we just call add on click. We call add. And we pass it our inputs, 5 and 5. Now, that would be a good way to call the function, except that value of 10 that comes back from our function would go into no man's land. It wouldn't go anywhere. So I could call it this way, but I could write a little inline JavaScript document get element by ID, and I gotta check my syntax on here. Dot inner text equals and then I call the function add. Okay, so now instead of that number 10 going into no man's land, I'm telling it to go into a output paragraph. I wrote a little inline JavaScript there on click. Let's see if that works. Okay, there you go. So we have both declared a function, we have called that function. This is a function declaration. Additionally, if you just wanted to run this on the page load or on a button click, just like we were doing yesterday, we could write a click event instead of doing it inline here, which I don't love. Right, like we were doing yesterday, we can grab the syntax for an event listener, paste in, whoop. Let's close it. Now document Okay, so we got a little string interpolation here where we're on the screen, we're saying 5 plus 3 equals, and then here is our curly brace, $ curly brace, calling the add function 5 and 3. So now we've got the event listener in the JavaScript file. I like that a little bit better. 5 plus 3 is 8. Okay. Point is, we have demonstrated a function declaration. Now let's do a function expression. And this is the idea that a variable can store a function. when I first saw this, I looked at this line of code for 20 minutes because I had never seen a function that we have right here on the right hand side of the equal sign. We are declaring a function on the right hand side. That function is called add3, like add 3 numbers. And we're storing add3 inside of a variable called addExpression. What's weird is to call this add3 function, you call addExpression. So if I go here, let's talk about the inputs and the outputs. There's 3 inputs. Here's your 3 inputs, A, B, and C. And then it has 1 output, which is just obviously those 3 numbers added. And to call that function, we call it by its variable name, addExpression 111. Well, sure, because this still says 5 plus 3. But notice we're adding 3 numbers. The third number happens to be 0. 5 plus 3 plus 1. 5 plus 3 plus 1. Okay, so this is a second syntax for declaring functions. You see both. You will see both. So it's like, well, why do we need multiple syntaxes? And it's like, well, number one, they exist. People use them. When you get into, for example, React, you'll be forced to use one, sometimes. You'll be forced to use a certain expression. But let's kind of view it in live server. Sucker button. There we go. As the note said, there's actually a third syntax for declaring a function, which is referred to as the arrow function. And an arrow function is an alternative to a function expression, to this one. And you're going to see you'll see that it looks kind of like a function expression to start. So we'll say const greet equals arrow, and then whatever we're going to say. Six ways to declare arrow functions. So I'm going to go through, and so when we have arrow functions, you work with them in a bunch of different ways. And the first way is no parameters. Notice that right there, those parentheses are where the parameters would go, but there aren't any. There are no parameters. And so this is the syntax. Now, I didn't mean to do that. There was a chunk of code that I found very useful when I was learning arrow functions, and I want to share that chunk of code with you guys. One rule, arrow functions are anonymous functions, meaning they have no name. So we're storing an anonymous function, a function without a name. Like basically here, this name add3, it wasn't very useful to us. Like we never used it, so we don't need it. And so you can not have a name, and that's referred to as an anonymous function. You would call this function by this variable name. Okay, so arrow functions are always anonymous functions. And so this function right here on the right side of the equal sign just is a function without a name. Okay, this function has no inputs and it returns hello. So that's how to look at this. We've got a variable on the left. We've got an anonymous function on the right. That anonymous function has no parameters, and it returns the string hello. Okay. MDN arrow functions. I found this little chunk of code very helpful. Where if you look at a traditional anonymous function, and just follow along with me, this function has one input, the letter A, and it returns A plus 100. So it has one input, one output. The first step in creating an arrow function is you remove the word function. So that you remove the word function and place an arrow between the argument, the letter A, and the opening body brace. So there's no word function, and there's an arrow. The second step was to move the body braces and the word return. The return is implied. So A, arrow, A plus 100. And then when you have one input, you can even remove the parentheses. So A, arrow, A plus 100. So the input here to the function is the letter A, and it returns A plus 100. I found this made a light bulb go off for me when I was going through my learning journey of trying to understand arrow functions. So I thought I would point that out for all of you. Okay, so we're going to continue with the ways of declaring an arrow function. I guess if I just wanted to call my arrow function by saying greet, and that way we could just demonstrate, call my arrow function, I call greet, it says hello. We can have arrow functions with one parameter. And literally that's what that code demonstration was. Const add 100 equals A return A plus 100. So now we're calling the add 100 function, passing in 5. Of course, it should return 105. By the way, original function, arrow function, right? That's why you hear it all the time. You hear syntax sugar, right? Functionally, they do the same thing, but this is a lot cleaner. Call add 100, and we get 105. So no parameters, one parameters. Then we get multiple. Now, when you have one parameter, notice the parentheses are optional. When you have multiple parameters, the parentheses are no longer optional. So on line 27, you'll notice I have multiple parameters, so separated by commas, A, B, C. Those are my inputs, and my output, what do we want to call this? Multiply. Returns A times B times C. Multiply 3. Does everyone see this one parameter, optional parentheses? When you've got multiple parameters, the parentheses are required. Call multiply 3. We'll pass in 2 times 2 times 2. 2 times 2 is 4 times 2 is 8.
6.
2 times 2 is 4. 4 times 2 is
Oh.
8. Refresh. Okay. By the way, parentheses are required for no parameters as well.
What's the E that goes in front of it sometimes? Then
The E,
sometimes it would be like E dot something event dot something.
I think you're thinking of something a little different.
Sorry.
It's fine. Okay, right here on the right hand of the arrow, this is the function body. Okay, on the right hand side of the arrow, that's the function body. This is the function body. Notice there's only one statement in the function body. Okay, a statement ends in a semicolon. We might have a function body with multiple statements. Then unfortunately what you have to do is you have to bring the curlies back. The function body is defined by a set of curly braces, and let's do something a little bit different. Const greet2 equals name. There's a default here, a default name of guest, arrow. Here's my curly braces. Okay. It doesn't really matter what I'm doing. What I'm showing you is that there's 2 semicolons. Each semicolon terminates a statement. At the end of a JavaScript statement is an optional semicolon. Because I have 2 statements, unfortunately, we have to bring back the curlies. So it kind of brings back some of the stuff that we took away when we have a function body with multiple statements. So call greet2. If I just call greet2 like this, notice I'm not passing anything in. It will assume the default name of guest. It should assume the default name of guest, right? So this is referred to as an optional parameter. That's not really part of this discussion, but I'm just showing you in functions they can take optional parameters just like in C#. Okay, they have optional parameters. But if I pass it a name, then it will take that name and greet Evan. Another syntax, if you need to return an object from your arrow function, there's actually a shorter syntax, I believe, where we could just do name, comma, age. So there's two inputs here. It returns an object. Now, I don't. And so if I call create user, now what this should do is it'll return an object, and we'll see how that formats my object. Call create user. Now, you see what it's suggesting here? There's a function to stringify the object. Let's see what it looks like if you don't stringify it. We're gonna use that JSON stringify in this class quite a bit, but nonetheless, let's just take a look. Refresh, sucker button. I might have done that. I was trying to shortchange this, but I might have broke it. So let me see if I throw my parentheses back in. I don't think that's going to do it. Okay, now we're getting at least an object back. So that's now let's replace this create user with an outer JSON.stringify. So stringify is going to take an object and make it into a string, turn it into a JSON string, JavaScript object notation string. And so now you actually can see the data that's in there. The name, the value is Evan, the age is a number of 40. So don't forget your parentheses there. That's how to return an object. Okay, now back to the theory. I said I was going to hit a couple of things here. Functions can be assigned to variables. I covered that. I also said I want to talk about higher order functions, where functions are passed as an argument into a function. Okay, so I'm going to talk about higher order functions for a second, which is a function can be an argument. Okay, this is a weird one too. So here's a function. This is a function declaration, like we just covered the first one, right? Here's a function declaration. Keyword function, identifier, 2 inputs, 1 output. So here's our keyword function. Here's our operator. We've got 3 inputs. Notice this third one returns the operation of A with 2 inputs on this operation. So this third argument will be our function. So I'm going to have two functions here, two more functions. So I'm going to have two operations. I'm going to have an add operation, and I'm going to have a multiply operation. Okay, so when I call this do math operation, I'm going to give it the first two inputs, like the numbers 5 and 5, and then I'm going to give it the operation. If I pass the add function to the operation, it will then call add 5 plus 5. If I call multiply, this return statement will return the multiply of 5 times 5. Okay, so let's see how this can work. So here, call do math operation. I don't need to stringify anything. Do math operation. It takes the first two inputs, just some standard numbers, 5 and 5, and then I pass the function add. Notice I'm not calling the function add. If I called the function add, I'd put parentheses on it. I'm not calling the function add, I'm just passing the function add. It's not actually going to be called until right there. So of course this should add 5 plus 5 and we should get the result of 10. Do math operation of 10. Of course, if I go back and I pass the function of multiply, again, this do math operation, this is weird. This is passing a function to a function. Right? Passing a function to a function is referred to as giving the term.
Functions and then choosing which function each one goes into.
Yeah.
Okay.
Yep. It's called a higher order function. So you got some new terms today, right? Higher order function, first class citizen, maybe a few more. Function declaration, arrow functions, function expressions. These are all new terms, probably going to be on that written test kind of thing. Yep.
I have a question. So when it says a do math operation, is that only for math, or is it like, did you like name the function, or is this like a function that was already named?
Yeah, I got to name that function.
Okay.
Yep. Yeah.
Like
So
functions that have names that only do certain things.
yeah, there's built-in functions.
Yeah.
So yeah, there's a whole bunch of built-in functions like, parse float. If you remember parse float,
Yeah.
that's that's one that's built in. All right, so that's an example of a higher order function. Those are the examples that I wanted to cover when it comes to writing functions and calling functions. I'm going to leave that on the screen. I'll leave this on the screen here while I pull up the next programming challenge. Programming challenge number 5. Create a string toolbox. I'm going to put this over here. While I pause the video and let you guys write some code yourselves. But this challenge, build a string toolbox with small functions and basic UI controls to run demos. Here's a list of the functions to create, the function syntax, and the inputs and outputs. So you're going to create a function called vowel count. You're going to create it using the function declaration syntax. If the input is race car, we got 1, 2, 3 vowels, and it's going to output the number 3. Reverse string, pretty obvious. It's a function declaration as well. So we got 2 function declarations. Input hello, output hola. How about that one? Capitalized words, function expression, so that's a different syntax. Hello world, lowercase, capitalizes the first letter of every word. Even if there's 10 words, you capitalize every word. Word count counts the words using the arrow function syntax. Concatenating strings, 2 inputs. The first input hello, the second input of world. Adds the strings together into one string. Returns one string of hello world with spaces between the words. That is programming challenge number 5. You've got 5 functions to create. A little bit of programming logic to solve them using these different syntaxes. I'll pause the video here before we go through the solutions. Okay, most of the students have finished, so let's go through one solution. Doesn't have to match your solution, but we basically declared and called a bunch of functions. And the first 2 are using that function declaration, keyword function at the beginning. They both take in a string. Then they perform some logic, and then they return a value. So the val count, you could see we've got a for loop on line 5. If that string of vowels dot includes, so dot includes is a method that belongs to, a string. So if a string includes one of the chars, it says, now we're using a for of, so basically that input string, that input str, that's what's coming from the user ultimately. So if the vowels includes one of the chars from the user input, then you increase the count and you return the count. The fun one for the reverse string, and several students came to this, where again you can manually do this with the for loop and an if statement, but built into JavaScript there's, as Anna was saying earlier, what are the built-in functions, and learning some of the built-in functions here, one of which earlier was the includes function, but there's also a split. So it takes a string and splits it into individual characters. Reverse, you can figure that one out, and then put it back together. So split it apart, reverse it, put it back together. Simple enough. Capitalize words. Now this one's different. We're splitting it, and then for each character, we're mapping each character. Okay, so we're mapping the word and char at 0, converting it to uppercase, and then removing that. That's what slice does. So getting an individual character, capitalizing it, and then removing that character, and then joining them back together. So capitalize the letter, remove the character, and put them all back together. So that's capitalized word, word count. If we kind of scroll down, now this was a different syntax. The line 17, that was the function expression. Line 24, we get into our first arrow function, which we only have a single. We could actually get rid of those curly braces and the semicolon. Nonetheless, we get rid of the white space on the ends. Dot split, filter each word where the word dot length is greater than 0s. Length to string, filter each word. So we have a string. That string has a bunch of words in it. I think that split. Split at the space. I'm sure that's what we're doing, right? So anywho, that's returning the number of words. Concatenate strings is an arrow function. 2 inputs, return those 2 inputs added together. We have a helper function called display output. So if you scroll down, display output, you'll see, if you just click on line 32 for me, yeah, you can see display output is called on all the button clicks. So go ahead and scroll down. So you can notice that the input.value on line 38, that's the text box. And then you call the function, pass the result of that function into display output. So val count returns the number of vowels, and then it says vowels colon, and then passes that along to display output. So it's just a way of kind of cleaning that up. Go ahead and demonstrate. Let's just kind of start with one string. So we got a bunch of buttons, one text box, and just put in a sentence, whatever you like. Put in a couple words so that we can mess with it. Okay, val count, reverse string, capitalized words, word count, and concatenate strings. Now you're going to say, well, what do you want to add to it? And you give it another word. So type in whatever you want. A lot. I like food a lot. Wonderful. Back to theory. A little bit more theory on objects. One more challenge for the day. So back to theory. Okay, so realize JavaScript objects. Now you should know what objects are from C#. Very similar in JavaScript, except for they're not strongly typed. In C#, everything is strongly typed. JavaScript, they are not. So what are objects? Object is a collection of related data and or functionality. So just like your objects in C#, you've got properties and you've got methods. Same thing in JavaScript. The data inside of an object is stored as key value pairs. So you guys, I believe, know what key value pairs look like nowadays, but we will go over it if you don't. Objects can hold many values, right? So a let variable holds a single value. Objects hold many values. It's like a container holding multiple variables. A good way to think of an object as a real-world entity. So a noun, a person, place, or thing. A real-world entity is an object. A car has properties like a color, make, and model. A person has a property like name, age, and height. So since it's a container that stores multiple things, the thing itself is the object. Okay, now if you store multiple of the same thing, that's what you have an array. If you have multiple of the same thing, that's your array. If you have a thing itself, that's your object. So a lot of times you're like, should that be an array or should that be an object? And it's like, well, if it's a noun, it's probably an object. If you have multiple of that object, that's your array. You can have arrays of objects. Objects are typically created with curly braces. Okay, you've seen this, right? Example. Constant car. Color property, value of red. Make property, value of Toyota. Right? So this is called an object literal notation. So the key is the property name. Color and make are your properties, and then the values are Toyota and red. You can change the color as your car gets older to pale red, right, using dot notation. So car dot color equals pale red would be updating a property. You could also use bracket notation. So car bracket color. Okay, dot notation is much easier. Okay, bracket notation does offer one benefit. Okay, and that's dynamic runtime assignment. Okay, we'll get into that a little bit later, but there is one benefit of bracket notation over dot notation. The benefit of dot notation is it's easier. The benefit of bracket notation is it offers some runtime benefits. And that's what you kind of see here. Bracket notation is useful when the property name is stored in a variable, car sub prop. And you actually saw that yesterday in yesterday's video where we were looping through an object. Objects also have methods. Methods are just functions. It's a word basically used interchangeably. When a function is part of an object, they call it a method. If a function is not part of an object, it's just called a function. Methods define behavior. The syntax for this, so here's our object. It's a dog object. It has a name property, and it has a bark method or a bark function. You say bark colon, and then you define the function. In this case, it's a console log that makes the dog woof. So dog.bark is how you call the function. There is a keyword that is commonly confused in JavaScript is what in the world is this? The this keyword refers to the current object. Inside of a method, you have access to that object's properties. So you say this dot name refers to the name of that particular object's name. So in this case, hello, my name is this dot name. This dot name refers to Alice, because you could have 100 people and they all have different names. Objects are considered mutable, meaning you can change their properties even if the object itself is declared with const. Notice here's a const called user with the name of Bob. You can update Bob's name to Charlie, and that is valid, even though Bob was declared with const. You can also add new properties, so user.age is 30. So we're adding a property after the object has been defined. But what you can't do is reassign the constant object to a new object. So user equals empty curlies would throw an error. So you can update the properties, but you can't assign it to a whole new object or a different object. That would throw an error. Okay, so let me do a little bit of code demo, and then we'll do a challenge. This code demo is going to be pretty basic. Okay, so we got user, enter a user's name, text user input, output button, paragraph ID of output. Okay, let's make our person equals curly braces means it's an object. Name is my property. You can have an array. Followed by a comma. Age is 40. It's like you know my occupation, software developer, that's good. Let's make a function for my bio. It'll return my name, sub 0, Evan, name, sub 1, Gudmested is that many years old and is a software developer. Evan Gudmested is 40 years old and is a software developer. So when I call that function, that'll be the string that gets returned. Equals person dot bio. So we're going to call the bio function that belongs to the person object, the bio method. Whenever you click here, open with live server. Evan Gumstead is 40 years old and is a software developer. Maybe we update a user's name. Let's do text user input on change. So document get element by ID text user input add event listener on change. On change. Now function E tells us a little bit about the event. E.target.value. So splitting it at the space, we'll make an array. New name will be an array. Then we'll update persons.name to new name. And then we can call this line to update the output with the new name. So whenever you change the text box, it updates the person's name and the output that you're seeing in the window. And let's see so Evan Gudmested. Now on change runs not every character, but when you tab off. When you tab off of the text box, on change runs when you tab off. And it only got the first two words on change because of how we wrote it. Person.name only has 2 spaces. But I wanted to show you an update, right? right? I wanted to show you an update because I've got an object and I update that object, right? I update that object here, person.name. I assign the name here, and then I update the name here, right? Because, why do I do that? Because that's part of your next challenge. Challenge number 5, creating a user profile. Create a web page that uses a JavaScript object to display user profile information. The user should be able to update one of the properties via a form input. Define a user object with a name, an email, and an isOnline. Display the initial profile when the page loads. Display the user's name, email, and on the page. Use paragraph tags to show the information. Create a form for updating. Add an input field to update the user's email, and then handle the update. Attach the event listener to the button. When the button's clicked, get the input, update the email property, and then redisplay it. Very similar to what I just did. That's objects. Let me zoom out here a little bit. Can you guys still read that okay, or is that too small? Well, this there we go. Get them both on the screen like this. All right, I'm going to pause it here. All right, we can go ahead and take a look at a solution. You can see here, Courtney, can you zoom in a little bit on your code? Just kind of, I think it's Control Plus will be the hotkey to zoom in a little bit. Yeah, there we go.
That better?
Yeah, that's a little better. Line 21 declares our user object with a name, an email, a Boolean isOnline, and a function. Line 29, different ways of doing this, but this is on the page load. We load the user.bio, and so line 30 puts the inner text of the output tag to user.bio. We have two change functions that one is targeting the user input and one's user input 2. And both of these are being used for the name, and very similar to what the code I wrote for the name. The other one's being used for the email and updating the email. And so that is, defining the object and updating the object when the text box changes. So could you maybe show the page in the browser when the page loads? Let's refresh the page.
It's already loaded in, so I can do it in. Drops it there. And automatically updates.
Yep, as soon as we tab off. All right. So that'll be it for today. We'll continue tomorrow, and we'll talk about some other labs to work on. Good job. We are going to continue with some of the JavaScript foundational concepts. And where we left off was after objects. So yesterday we really talked about functions and then objects, and we did a couple exercises. We have two new concepts today, one of which is really, well, they're both interesting, but I find asynchronous programming to be kind of a modern, interesting way of writing code. The first note I put on here about JavaScript being garbage collected, maybe you guys are familiar with, like, I remember learning C++ in the 90s, and learning C++, when you declared a variable, you made a new variable, you had to, that was allocating RAM. That was consuming your computer's RAM. you also had to write logic to clean up that variable and release the RAM from the program back to the operating system. And if you didn't do that, if you wrote some code that did not, if you took RAM but you didn't give it back, that was called a memory leak. And you see that on your laptops nowadays. If you guys never reboot your laptops, eventually it kind of starts to slow down. Okay, so these are examples. That's an example of software that consumes resources like RAM from your operating system. It takes it from the operating system and doesn't really give it back properly. And so old languages like C++, you had to write that logic to release the RAM to give it back. Okay, and then Java was really the first one that I studied that they just automated that process where your software was like that. Giving the RAM back was automated. They just call it garbage collection. It's done automatically for you. It's in the background, and that's how JavaScript works. So like the short version is you really don't have to worry about it because it's handled for you. It's automatic. So it prevents memory leaks and it simplifies memory management. Okay, so that's really all I have to know about JavaScript and its garbage collective nature. It's like a program that runs in the background and it releases the RAM if it can, kind of deal. That's the garbage collector, it's called. Oh, is there background? Do you hear an echo?
Yeah, somewhere.
Let's see. Brody, could you mute? Nia, could you mute? Does not look to be the case. Maybe. There we go. Cool. Thank you. Okay. All right. So garbage collection is kind of automatic. It's not something you have to code. So it's a theory. It's a theoretical thing. It's nice to know. It's beneficial whether you realize it or not. You get the benefit of garbage collection. Something that is something you will have to code. And it's very modern web development is writing asynchronous code. Right? Synchronous means kind of at the same time. You know, when we have a synchronous remote class, like we're just interacting at the same time. Asynchronous means it can happen at not at the same time, but at different times. And so you might call that multitasking. Asynchronous code is how we write modern web development. Websites rely on a lot of outside resources. So you make a request for an outside resource, like a piece of data, like what's the temperature? If your website's displaying the current temperature, you're going to make a request to some outside resource, like, hey, what's the temperature? And you're going to receive that data. You don't want your website to sit there and spin while you're waiting on that response, that request response. So most modern web programming is written in an asynchronous format. So it's really important to understand that, well, JavaScript and C# and these languages can be written in an asynchronous format. And there's a little bit of theory that goes on, again, behind the scenes. And this is just interesting, good to know theory. So JavaScript is non-blocking. What does that mean? That means that you write JavaScript and it shouldn't block your browser from functioning. Your browser should multitask, meaning it should continue to load the page and not block the page from working, right? If you write in an asynchronous format. Okay, so how this works, there's a few terms here, okay? And you know, these are terms you'll probably see on a test somewhere eventually. But let's just get this down. The call stack. Okay, call stack, the event queue, and the event loop. So there's three terms. The call stack, the event queue, and the event loop. So let's get through some terms. And we see that starting with the call stack, we see the call stack is where synchronous code is executed. So synchronous means one step after the other. Is everyone with me? One step, line 1 before line 2, before line 3, before line 4. Most of the code that you guys have written has been synchronous code. It executes top to bottom. So it's kind of an easy concept to follow because that's what you've been doing so far. All of you have been writing synchronous code. And the call stack just says this is the first instruction, this is the second instruction, this is the third instruction. It works on a last in, so like the last instruction in is the next executed instruction. Like the last instruction you read is the first out. Last in, first out. The last instruction in is the first out, one at a time, one after the other. You could call this when one instruction is pushed onto the stack, that then executes and then it's popped off the stack. So that's just like the last one in, first one out. Last one in, first one out. Line 1 goes into the processor. It comes out of the processor after it's been executed. JavaScript is single-threaded, meaning it can only execute one thing at a time on the call stack. The problem with the single thread is if a function takes a long time to complete, it would block the call stack. So line number 2 is taking a long time to complete. The web page freezes, right? It makes the web page feel unresponsive. You know the number one reason people leave your web page is if it feels unresponsive. If your website starts spinning, that is the number one thing that will cause people to leave. Okay, so that's the problem. We can't have that. We need to fix that. So how is it fixed? It's fixed with what's called an event queue and an event loop. To solve the blocking problem, JavaScript uses a clever system for asynchronous tasks. When an asynchronous operation, and you get to define an operation as asynchronous. One asynchronous operation that's built into JavaScript is the set timeout. Do you guys remember set timeout from last semester? A couple people nod their head.
Vaguely, yeah.
Vaguely. It's a timer. You say execute this after 3 seconds. Okay? When asynchronous operation like the built-in set timeout, or for example, a database request or an API call or a network request, these are asynchronous operations. That asynchronous operation starts and then is handed off to the browser's API. It's basically handed off to the browser's set of instructions, the browser's API. The call stack doesn't wait for it. It immediately moves on to the next line of code. So when your browser hits an asynchronous task, it starts the task and then passes it off and lets that task finish elsewhere. Once that asynchronous task is complete, its callback function is placed in the event queue. So the callback function is basically a function that runs once the task is complete. That task has a callback function. It's a function that runs once the task is complete, and it puts that in a queue, in another queue called the event queue. So, I think of like the call stack is the synchronous tasks that are running. The event queue is like, hey, here's some asynchronous tasks that have completed. It's a separate queue from the call stack. Call stack executes top to bottom. Event queue is a set of asynchronous tasks that have completed. It's its own line. It's a separate line. Call stack is one line, 1, 2, 3, 4, 5, these instructions. And then the event queue is a separate line. These are completed asynchronous tasks. Okay, then you have this thing called the event loop. The event loop is a background process that constantly monitors two things. Is the call stack empty? And are there any callback functions in the event queue? If the call stack is empty, so the call stack is the synchronous. If the call stack is empty, the event loop says, hey, here's a callback function to run. Go ahead and run it. And so, again, there's a lot of new terms in there. If that's kind of cloudy, I understand that. And so I made this analogy to help understand. Because there's a lot of new terms. So we have a chef in a kitchen. A chef in a kitchen. So imagine the chef is the call stack. So they do one thing after the another. You can only do one thing at a time as a chef, right? That's your call stack. That is your synchronous execution of code. All right, and again, just as a definition, synchronous tasks are like chopping vegetables. The chef must do it themselves, and they can only chop one vegetable at a time. Asynchronous task is like baking a cake. The chef puts the cake in the oven and sets a timer. They just don't stand there and watch the cake bake. Instead, they move on to chopping more vegetables. So you can imagine you're chopping vegetables and you decide to bake a cake. You go put the cake in the oven, right? That's your asynchronous task. Then you go back to chopping vegetables. The oven timer is the event queue. So that event queue, that's the asynchronous task is done. The timer is like dinging, letting the chef know. The chef is the call stack. It's like, hey, timer's done. You can go work on the cake again. So when the cake is done, the timer goes off, the event queue goes off, and the chef hears it. The event loop is the chef's ears and brain. When the chef has finished all the chopping, the call stack is empty. They check the timer, and if it's ringing, you hear the ring and you see, your brain says, okay, I can go back to the cake. Meaning the event queue has a task. So the event queue, there's an asynchronous operation there that is finished. You can go to the event queue. If it is, they take the cake out of the oven and finish decorating it, which means execute what's called a callback. Again, what's a little confusing is a callback function is a function that executes after the main task is done. Right? So a callback function is kind of what it sounds like. You execute the function, and then you execute the callback function when you can. Okay. All these terms enable asynchronous programming. And I'm going to do a demonstration of this. I'm going to do a demonstration of asynchronous programming that will help you understand a little bit better, regardless if you understand event queues and event loops or call stacks. Okay, but that's the nature of how this works. Now there's one more thing I'm going to add to this, and we cover this later in the class. There's 3 ways in JavaScript to write asynchronous code. Okay, just so you guys all hear this now. Callbacks is one way to write asynchronous code if you're writing your own. Promises are another way to write callbacks. And async await, who was asking me yesterday about async await? Someone in this class was. We're all here. Someone was asking about async.
Quinn.
No, it wasn't Quinn. Deshaun, you were asking me about async await yesterday.
Yes, I did.
Yeah. Okay. Async await is the 3rd way to write asynchronous code. So again, there's some things built into JavaScript that are built in as asynchronous functions. The one function that I highlighted here is a built-in function called setTimeout, and that is an asynchronous function. Okay, and then you can also write asynchronous functions. Again, the way the web works, it's kind of a wild place, and you're pulling data all the time from different sources for your website. And so you need it to operate asynchronous. It's just a more efficient model than synchronous programming. Okay, that's like the most simplified way of putting it. Asynchronous model, you don't always write asynchronous code, but if a task takes a while, then it makes sense to write it in an asynchronous format. That way you're just not waiting. Okay, you're not just waiting on that task to complete, right? A database request, a network request, file I/O request. Timers take a while to complete, so write them in an asynchronous format. Okay, these are all examples of it's like, hey, you can start a task and then continue executing your code, and when that task is done, then you can run its callback function. And so again, if this is still cloudy, I understand. I've been studying asynchronous code for years, and it's still a concept that this technical, what I just got into, the call stack, event queue, event loop, You know, if you were to catch me on the street and quiz me on it, like I don't know if I have it down perfectly yet. Okay? However, that doesn't mean it's hard code to write. Okay, that doesn't mean that we can't learn how to write asynchronous code. Okay, we understand it's important, and we have to understand the syntax, a little bit of the technical, how does it operate, that's good. Okay, let me do a code demonstration. Okay, and then you guys are gonna have a programming challenge. So as I've done, I'm just gonna make an async.html and copy that and paste it, call this my async demo. And this is my H1 is just going to say async demo. Okay, you guys do not have to write this. At this point, I would ask that you just kind of observe. Okay, and the first thing I'm going to do here is make my async JavaScript file, and I'm going to link up my script to my async.js, or my HTML to my JavaScript. Notice the defer attribute in the head. You guys, we talked about why we do that. Okay, so I'm going to start with some synchronous code. Okay, and in my synchronous code, as you know, everything, and I got these fun little emojis, right? Everything's going to operate top to bottom, real simple. Now I'm going to have a function called brew coffee. I'm going to have a while loop. By the way, this while loop. So we have a variable called start. It is equal to this very minute and this very second. And we loop. We're going to have a while loop while the date dot now of when this is executing minus start is less than 3 seconds. So anything under 3 seconds, 3,000 milliseconds, 3 seconds. So continue to loop while the current time is less than 3 seconds old, right? Because your start date minus 3 seconds. Okay, so this simulates.
0.3?
No, 3,000 is that's 3,000 milliseconds or 3 seconds.
Okay.
Okay. And then when that's done, when that while loop is done, we're going to say coffee is brewed. We are going to call this function. Okay, so we made a function called brew coffee. We declared it using function declaration syntax. We call that to brew coffee, and then we drink coffee. Pretty simple synchronous code, right? Everyone's seen this kind of synchronous code before. You're very familiar with it. If I launch this page, watch the spinning. You guys see the spinning? That's the important part there, is that task is taking 3 seconds to complete. That's blocking code. That is blocking your browser from continuing to do anything else. And spin, and again, the number one reason people leave your website is if your page is loading slow. That spinner, raise your hand if you've ever left a website because of a slow spinning website.
But usually,
We all have.
but isn't it sometimes not the website's fault, but like the connection or something?
Yeah, I'm sure, yes. Yes, that can be the case. But either way, if you have a poor connection or if it's poorly written code. I don't want it to be on us. We can let it be on the network engineers. I don't want it to be on the developers. Okay? Okay, so that's a problem with your asynchronous. And basically what we've written is a while loop that takes a 3 seconds to finish. All right, in synchronous code, it's slow. Okay, let's modify this to asynchronous code. Remember, there's a timer that I mentioned. It's going to be the solution here. So here we're going to update this to async code. Okay, and here, console 1, order a coffee. Set timeout is a function. We're going to write an anonymous arrow function. Whoa, anonymous arrow function. This, what goes inside of set timeout, is what's referred to as the callback function. This arrow function will execute after the timer finishes. This is referred to as the callback function. The callback function says the coffee is brewed, and I'm going to set this timer to take 3 seconds to execute. 3,000. Semicolon, semicolon. Console log, then drink the coffee. Okay, so this is asynchronous code. How is it asynchronous? Because this function, set timeout, is a built-in asynchronous function into JavaScript that executes a callback function when it's done. Let's take a look at how this executes. And I like this example and I dislike it at the same time because it's like, wait a minute, this makes no sense. Let me refresh. Notice task 1, order coffee. Task 3, drink the coffee. Task 2, coffee is brewed.
And it happens every 3 seconds.
It happened after 3 seconds. Now ignore these errors, they're meaningless in this example, but let me just refresh the page one more time. Task 1, order coffee. Task 3, drink the coffee. Take a look at what we were looking at before. Watch this spinner. Everyone watch the spinner? We're not spinning. Okay, does this example make sense because you're going 1, 3, 2? Nah, it kind of falls apart. The example kind of falls apart because you can't really drink the coffee before it's brewed. That makes no sense. What is demonstrated here, though, is the power of asynchronous programming. That function, that callback function, ran after the other synchronous tasks were done. So the page didn't hang. Everyone with me? That's the benefit. The page didn't hang. Say it with me. The page didn't hang. That's the benefit. Thank you, Deshaun.
I said it in my mind.
Thank you. Thank you for saying it in your mind. The page didn't hang. Who cares that it goes task 1, 3, 2? That's not the point. That doesn't make sense. Okay? But the benefit here is you have now written you've watched your first asynchronous demo. Okay, and with that being the case, I'm going to have you write some asynchronous code. It's all going to be with set timeout. It's going to be on managing multiple async tasks. Okay, I want you to create a web page with 3 buttons and a display area. Each button, when clicked, will trigger a different task. So one button click will say brew coffee. Another button click will make toast with a 3-second delay, a 2-second delay, or a 1-second delay to, what are we doing? Pour juice. Coffee, toast, and juice. The goal is to show a loading message when a button is clicked and then display the success message for that specific task after its unique display. Okay, so this is going to kind of show you, you're going to click a button, it's going to say loading, and then when the task is complete, you'll see the brew coffee or whichever button you clicked. All tasks should run independently and not block one another. For example, a user can click make toast and immediately click pour juice, and both messages should appear after the correct delays. You're going to have 3 buttons with unique IDs, and you're going to have 3 paragraph tags for the status. And the status will either say loading or it will say, coffee brewed. Okay, so there's the task. I'm going to put this as I've done. I'm going to put this over here. And I'm going to put the JavaScript code over here as I pause. Okay, 3 buttons, 3 event listeners, 3 different timers. And let's get to it. Okay, kind of looking at a solution, and this is not anything that really is overly complex. It's actually quite simple. We got 3 button clicks. You can kind of see those in the different chunks of code, and then inside of each button click, we set a paragraph tag to say loading, and then we set a timeout for 3 seconds that says coffee brewed. Same thing, button click, set timeout, says loading, set timeout. Toast is made, 2 seconds, same thing for the juice poured. And then if you could just switch to the browser and kind of refresh the page and just start with the blank page, click all 3. You can see they're all on 3 separate timers, 3, 2, 1. The point is they're not blocking one another, non-blocking event loop. They don't block one another. Right? If these were in while loops, every one of these would block one another and your page would spin a little bit more. Okay? So it's a simple example, but I think it's a powerful example because it shows you asynchronous code. You can continue to execute the call stack, and then when these async functions are done, go to get their callback functions. Awesome, thank you. Let me switch back to the lecture. Okay, and this is another big one. This is another big one on what are called ES modules or ESM. ESM. The alternative is called common JavaScript, just what it sounds like. .js files are common JavaScript. They've been around forever. ES modules, you can kind of see it right here, allow us to share code between files. It's weird to think that JavaScript was around for so long without this feature. But you can see here, ES modules were actually only introduced in ES6 or ECMAScript 2015. So this feature's only been around 10 years. So it's a relatively newer feature if JavaScript has been around since all the way up here. We learned JavaScript was around in 95. Okay, so in that sense, it's a newer feature. Again, allowing us to share code between files. ES modules are JavaScript's official standardized way of reusing code across different files. Well, that's nice. You write it once and you can use it a bunch. Again, you would think that that would have been around for a while, but it just wasn't in the way that it is now. They allow you to export code from one file and import it to another, which helps you break down larger applications into smaller, manageable pieces. The expression comes to mind, how do you eat an elephant? One bite at a time. Big problem, you solve it in small, reusable code chunks, reusable bits of code. This approach improves code organization, reusability, and code maintainability. Again, introduced in 2015, and it came around in the Node world in 2021. You know, I learned Node around that time, so it's been around ever since I've learned Node. By default, all the code in a file, and you can also call a file a module, is private to that file. At its core, ES modules have 2 statements, an export and an import statement. Okay, now an export falls into one of 2 categories. You have a named export or what's called a default export. You're allowed to have many named exports, but you can only have one default export. So when it comes to a named export, you can export variables, you can export functions. Okay, so you can export a piece of data or you can export a function. I mean, that's basically what JavaScript is, a bunch of variables and a bunch of functions. Yes, we will use this in React for sure. We will use this all semester long. So I guess the point that I missed here is that you have the keyword export in front of your variable name. And that's how you do a named export. Or you put the word export in front of your function name, and that's how you're going to export that individual function. So that's the keyword. You just put it in front of the variable or in front of the function. A default export, you can export one called, consider it a main thing, from a module. So your file can have one default export. You can have many named, but you can only have one default. And that's done with the, you say export default. So export default. Okay, and because you can export them differently, you import them differently. So you have, again, named, and you have defaults. So in order to import it, when you have an import, when you're importing named exports, you put them in curly braces, and then you give it its path. Okay, you're importing these two, my variable and my function, as we exported them here, my variable and my function. But you have to put them inside of curlies. This is called object destructuring. Okay, we'll talk about that fun word destructuring, and we'll talk about object destructuring and array destructuring. This is how you bring in named exports. However, you notice a default export, you just don't put curlies on it, and you can only have one. Import my class from the name of the JavaScript file. Okay, it allows you to use code from other developers. That's going to be very powerful, so you don't have to recreate the wheel. Okay, we're going to be using a lot of code from other developers for that reason. We're not going to recreate the wheel here. If you're using Node, you can either have the file extension. By the way, MJS is a modular JavaScript file. So these ES modules, if it's a .mjs, that's what that means. It's a modular JavaScript file, MJS. That's its file extension. And you want to set the type of module in your package JSON. We'll talk about that. Okay, let me demonstrate a little bit of code here. All right, we did a little async stuff. Now let's do a little bit of ES modules. And this is another kind of basic, just 101. Let's go ahead and create a file called modules.htm. Let me copy this from over here. There we go. Copy this over here. It doesn't matter. I just like my bootstrap. I like having my bootstrap stuff. And I'm going to link to modules.js. And it's going to put a h1. Classes text primary. This will say modules, ES modules. ECMAScript modules, ES modules. The alternative is CommonJS, CJS or MJS. I'll make a JavaScript modules.js. Okay, now in the JavaScript world, there's one, if we're not doing Node, which we're not right now, I didn't talk about this in the theory, but you need a type attribute of module. So you don't have to name it MJS if you have a type of module here. So I need to make a modules.js, and I have that. And I'm going to make one more file here called utilities, or utils. Utilities.js. And inside of utilities, I'm going to export function greet name console log hello name. Is this a default export or a named export?
Named export.
It's a named export. Doesn't have the keyword default. If it had the keyword default, it would be a default export. This is a named export. Okay, so this is a function called greet. It has one input parameter called name, and it returns hello with the name inside of it. Over here, how do I import a named export? How do I import a named
You do
import?
utils.
Well, it's from utils.
Import greet from
Now, what's missing?
the curly bracket.
Curlies, yes. When you have a named, you need to put the import. So now I have this function that's available to us, and you can see the copilot here is telling me just call greet. This function was written in another file. So I'm going to call that function. I'm going to pass it a string. Actually, I need to put the word world here. And it's going to say, world is going to come in. It's going to say hello, comma, world. Pretty simple example. But what we did here is we took a function, we exported the function, we imported the function, and we called that function. We passed it an input argument, and when I load this, of course, what we should get very simply is hello world. Not the most impressive output, but it does demonstrate ES modules. Okay, very simply covering this concept. It's not a hard concept to grasp. You're sharing code between files. It's done with an import keyword and an export keyword. It's important to see if you've never seen it before. However, not, and the syntax is interesting, right? If you have a named versus if you have a default as the notes talked about. Okay, let's pull this back, and let's pull this back and get to our last programming challenge. Now, you may want to actually access this document because I made these code blocks where you can actually just copy the HTML.
Is this CSS or the HTML? Oh,
This is HTML with embedded CSS. Yep. So what is this programming challenge? It says fix a broken web page. Your task is to fix the code so that when you open the HTML in a browser, it displays a color name and a random number. Okay, so if you kind of go through here, I'm going to give you some code. App.js, here's your JavaScript file. This is the main entry point. It needs to import functions. And then utils.js, we're going to export these functions to make it available to app.js. So my recommendation here is on Inside Ranking, you guys will have access to this. Unless you want to manually code that, I wouldn't want to code that. That's a whole lot to code versus if you're watching this in the future, what I would do, you might have to manually code this if you don't have access to the document. Pause the video here and code your HTML. So pause right here. Go ahead and code it. And then pause right here for your app.js. Code that. And then in the future, you could code utils.js by pausing it here. Everyone else, if you have access to the document, copy and paste the document. It's not a lot of code to fix. It's just a little bit. You got to export and import some things. And I'll pause now. Okay, let's go through and answer. And so in our world, probably on this index.html, the first thing to fix was the pathing. Now, app.js, what line 35 says is that app.js is in the same folder as your HTML. So if you put it in the same folder, then that's fine. Or if you had it in a JavaScript folder, which I know a lot of people put their JavaScript files in a JavaScript folder, you just have to say js/app.js. So one way or another, that was a fix. Let's go to the utils.js file. And here, now, this is good. I like this because Nia put the export at the bottom. Notice, instead of saying export function and export function, you can do an export at the bottom of the file. That's actually not a syntax that I had in my notes, but that is a very common syntax to do named exports. And so what we have there is kind of like on the import side, you get the curly braces around the names. So that's good. So let's go back to app.js. And then line 2, we got import get random color, get random number. And I believe lines 5 and 6 actually had different method names there. And I think that you had to update that as well. You changed them to the actual method names that you imported. Yep. So not a ton of things to fix, but there were a few steps there. And then thus the working page. Nia, if you can refresh a few times and just more or less, there you go. You get a random color and a random number. Problem solved. Okay. That's all I had for today. Just these 2 more programming challenges. I'll stop the recording here.